So welcome to our second project, which is going to be to create a snow system. Now, snow at the particle simulation side of things is very similar to our rain setup that we created in the first project, in that we have particles being emitted into the scene, which will be our snowflakes, or aggregate snowflakes, and we then have them falling with gravity, and we have their maximum speeds dictated by their size. So it's very similar, but obviously there are lots of variations or differences between the two in real life. You know, obviously snow is actually quite a lot lighter. It's less dense than the water of a raindrop, so it falls slower. It also can be, and because it's lighter, it obviously can be churned up much easier by turbulence and wind and that kind of thing. So we're going to deal with that. Then we can take a look at how the snow settles and how it gathers on the floor. When it hits the surface, it doesn't bounce away. It actually sticks to the surface that we've set as the collider. And also a little bit about how we can create a simple way of melting those particles away so it looks like we've left some tracks or trails. And then also we can look at a bit of rendering, so how to light it and how to make it look like one solid surface. Okay, so let's start building our snow system. First thing we're going to add is the system object to keep things tidy. I can rename it underscore snow. There we go. And we can change the color of it if we like. And I like to hide the icon in the viewport because I find it gets in the way sometimes. So I'm going to do that. And I'm going to add an emitter. So that's the first thing we're going to do. And we could have started with our rain setup. So I could have used our preset we created in the first project, but I feel like it's good practice to just start from scratch until you get really used to things, and then you can start using the presets. Although presets can be really valuable in time-constrained circumstances. So you're welcome to use the rain preset and then start from there. But for now, we'll go from scratch. So I'm creating an emitter. I'm moving it into space wherever I like. I might make it 5 meters by 5 meters. Oops, going way big, 50 meters. There we go. Lift it up off the ground quite a ways. And then I press play and we'll see we're getting particles added to our scene. That's cool. Now I'm going to give them their radii, so the various radius. And I could give them an initial speed, but we're going to be overtaking the speed using gravity and a speed limiter. So it doesn't really matter what speed we input here. We can override that later. So I'm going to go to our emission tab where we find our emission parameters and our basic particle data. And currently we're emitting 1,000 particles per second. I can increase that or decrease that as I like. I might just jump it up by double just so that we're getting a bit denser particles. I zoom in so that we can see that nice and clear. And then I'm going to change the radius. Now, we want to change these. We want to actually see something happening in the viewport. So I'm going to go to our display tab because in dots mode, in display mode dots, we won't see any radius change. We need to go to one of the other ones. And I'm going to use circle. Circle's definitely my favorite for being able to see the radius. Okay. We'll deal with color in a minute. We'll go back to our emission tab. Go down here and we've got our radius settings. Now, I've looked this up again, and I know that snow has a radius of a diameter of between sort of 0.1 centimeters and 1.5 centimeters. And that's not a snowflake, by the way. That's a sort of aggregated snow, so it's a bunch of snowflakes stuck together. We're not dealing with so much with individual snowflakes here. So I know that the radius needs to be sort of in between those two values. So I can do somewhere, say 0.7, something like that. And then like a variation of 0.3 or should we say 0.4? No, let's go for 0.3. So we know that the maximum is 1. Oh, maybe it should be higher actually. Yeah, let's go for 0.9 and a variation of 0.5. There we go. That's going to give us a decent range of particle sizes. Let's press play. Let's see what we get. And there we go. Our snowflakes or aggregate snowflakes are varying in size, and these vary way more than raindrops do because they sort of stick together. They kind of cohesively stick together when crystals kind of form on them. Okay, so now we've dealt with that. We could add some variation in speed if we wanted to just kind of get a rough idea of just standard falling snow, but we're obviously gonna, like I said, we're gonna override that. Okay, cool. Next up, we're gonna add some modifiers. So let's add a gravity modifier. So I can go down to our modifiers null, grab a gravity modifier, and there we go. Accelerating extremely fast and continually accelerating until they've left the scene space quite far. And then obviously we're going to need our speed limiting. So go back to our modifiers, go to motion, and go to speed. I can put that under the gravity. Not too important, but Cinema 4Ds executes objects from top to bottom of the object manager. So if you want something to occur after another modifier, it can be good practice to put it afterwards. It's not essential because sometimes they can work together, but it's just, I find it good practice to do that. Okay, so exactly the same as we did in our rain setup, I created a speed modifier, or added a speed modifier that does not add any speed to our particles, so I can set the particle speed change to 0. I only want to limit the maximum speed, so I activate the clamp maximum speed, and then I need to work out what the top maximum speed of a snowflake, one of our snowflakes, is going to be. Now, again, Google's helped me out here, and I found out that your average snowflake varies in its maximum speed by between 1 foot per second to 6 feet per second. So I need that in metrics because that's the clearly the superior metric, the superior measurement system. So what I can do in Cinema is quite handily is it'll convert. If I put in an imperial value, it'll actually automatically convert that value to my current units value, which is great. So I can just type in 6 ft for 6 feet, press enter, and I get this maximum particle speed of 182.88 centimeters per second, which is great. That is a quick and easy way of converting your parameters. I'm actually going to just nudge it to 200 just to make it a nice easy round number. And now, obviously, if I just press play now, and let's change our display mode actually. Basically what's happening is our particles are all being limited to 200 centimeters a second. So let's go into our display tab of our emitter. Let's change the color mode from single color to gradient parameter. And currently it's set to age, so you can see as they get to the 90 frame limit of our timeline here, they turn white. But we want this to be for speed. And what we can do here is we can just set the maximum to 200 because we know that that's going to be the maximum speed they're ever going to reach. Let's make the gradient a little bit more interesting. Let's go for, I don't know, let's add a few colors. Doesn't really matter what you use. It's just as long as you can identify points along this gradient. So we know that the end of this gradient is turning these red colors. I might make my viewport dark actually. So let's add a sky object. I'm not even going to add a material. I'm just going to use color on. Just make it black. There we go. It's the lazy way to create a dark viewport. And so you can see some particles do emit under the speed of 200, but they actually then hit that maximum speed of 200. And what we could do is we could actually say go to 300 on the minimum and maximum speed parameter, and we'll actually see that this is proof that they are not exceeding that 200 value. So if they were exceeding the 200 value, they would go to this red color and stay that red color. So you just find uses for this color mapping gradient because it's very useful to analyze your particle speeds and things like that. Okay, so let's go back to our speed modifier, and now we need to deal with mapping again. And obviously, I said before, it's quite an advanced topic in itself, but if you start getting used to it early on, you'll realize how beneficial it is to you. It can even avoid you having to create questions and action setups. It can simplify things dramatically for you. So I'll go to our mapping tab, and we need to add a map, because what we're going to want to do is we're going to want to set the larger particles to the higher speed limit and the smaller particles to a low speed limit. So I'm going to add a map, and currently the parameter in the modifier this side is the wrong one. We need to change that to particle speed maximum. And just to demonstrate, I'll go to the object tab, and we know that this is the parameter that it's referencing. So particle speed maximum is the parameter that we're going to drive or map to via our whatever we want to map the data from the particles. So currently it's age, and you can see as it goes from 0 to 90 frames, the particle speed limit increases over time. So you can see they start to accelerate down over time, but we don't want age. We actually want to use radius. And currently, obviously, our radius range is totally out of whack. And I don't need to actually, I did this in the rain setup, but I realized you don't actually need to set a minimum range here, because 0 to 0 will mean a particle of 0 radius will go at 0 speed, but we actually don't have any particles of 0 radius. So I don't want the smallest particles to go 0 speed. So actually, if I leave that range at minimum 0, we're not going to have any problems. The only important one here is the range maximum. So if I go to the emitter, go back to our emission tab, shrink down the emission parameters, and take a look at our basic particle data here. I think I just said basical, which is a new one. See, the radius is 0.9 with a variation of 0.5. So we know that it goes up to 1.4 and then down to 0.4. So we don't need to worry about the lower value. But 1.4 is the important one. So 1.4 into our map. And there we go, we're starting to see something interesting happening. So our range of speeds is we know it's from 0 to 200, and we can see all the particles moving at different speeds. If I pause, I know that the smaller particles are going to be moving slower, and the large particles will be moving much faster. And you get this really nice natural mix of speeds. And it's not just an arbitrary randomness. It's actually physically accurate, or within reason. So if I change this mapping, I've just realized that a curve doesn't help us here. We want a linear relationship between the speed limit and the radius. So I'm going to change this to, you just right click the graph or the curve, and you go to spline presets and linear. So that's fine. That just means we'll get a better distribution. There we go. Okay, so next up, we're going to actually add some turbulence to the particles, affect their direction, not just their speed and radius and that kind of basic data. And we need to do that by adding a turbulence modifier. So I can add that from loads of locations. I could use our null. We could go to our system object. We could go to our xparticles menu. We could use the commander. So if I put xptu, there you go, turbulence. Could all do that. I'm going to add it from the system object just to show one of the different ways. So motion modifiers, turbulence, there we go. And like I was saying about the modifier stack, it occurs from top to bottom in Cinema 4D. So we need to be cautious here, because I know that I want my speed to always be limited to this. Even though it's the falling speed, technically, if I put our turbulence below, let's see what happens actually. So if I put my turbulence below, go to the object tab, and I overdrive it, dramatically, these particles are now going far beyond the if I could do that, it's even more obvious, way beyond the 200 speed limit that I set in the speed mod. But if I drag it above the speed, you can see immediately they drop back down to their 0 to 200 limit. Okay, so that is important in this scenario. And you could choose if you want to overdrive the particles, if you want them to go faster than that speed limit is initially allowing them, because technically that speed limit is a terminal velocity. It's as fast as they can fall to the earth, whereas, maybe there's a gust of wind or turbulence that actually can move them faster than that terminal velocity. But in general, I think we're going to stick with it above so that we actually do get the speed limit going on. This is obviously way beyond the sort of motion that we want to have on our snowdrops, or snowflakes, sorry. So we want to drop the strength down. We go for something like 50. There we go. We're getting some really nice drifting here. You see they kind of move side to side. And we could drop the scale down a little bit, perhaps. If we go really low down, it's hard to actually see what's going on unless I increase the strength. That's a really jittery, energetic motion, which isn't very suitable for snow. We want a nice gentle kind of drifting overall. So if I drop the scale down, maybe increase the strength a touch more. And I can play with frequency as well. The frequency is sort of the frequency of the noise, if you like. I might try a different. I could use a different turbulence modifier. Sorry, mode, noise type. I could use curl. Now curl is, if I drop that back down to 1, the problem with curl is that it will take over the particle speed. So you can see here it's absolutely dominating the particle speed and they're set to a very low value. So if I actually, these curl options down here, if I turn blend and add to 0, we get the no effect. But if I increase the add value with no blend value, I think we're seeing some movement there. I think we still need some blend. So what it's doing is it's blending our original motion with our speed. And there's a balance point where you'll get them and they actually have a good effect on the particles. There we go. Increasing the strength. Yeah, I think there's too dominant. Curl is a beautiful noise type, but it's just it takes over too much. So you end up with a very jittery or perhaps too, so if you look here, if I go to a larger scale, you get this really nice motion. However, it is just taking over the particle speed. So let's go for I don't know, let's try wavy turbulence. It's good to just mess around, try see what you like. But I'm not really happy with any of these. I think I'm going to go back to our standard. And there we go, because the strength value is really high. It's too much. But I like the motion, so I'm going to kind of go for somewhere in between. Tweak around until you're happy. There we go. I think that's nice. You're getting some particles sort of drifting off to the side. They're kind of floating around. Snow, if it's really lightweight, can sometimes even reverse and go back upwards. So you might want to find a balance there where it actually really throws the particles back up in the air. So there we go. And we can also layer this up. So we could have one turbulence doing sort of the smaller motion, and then if I duplicate it, Control or Command dragging it, and then we change the scale of this standard turbulence, we can actually layer them up and we actually get 2 sets of turbulence, which actually is probably more realistic, where we'd get, you know, thicker air pockets and sort of smaller motion in some. But for now, I think we'll just we could stick with something like that, where we've got 2 turbulence modifiers drifting the snow around. It looks quite nice. So that's our basics for our snow, for falling snow. Next up, we're going to deal with actually how it collides with surfaces and settles on them.